Hello aspirants, welcome to Science and Tech course by UPSC Experts. See, now we'll be dealing with space technology, right? See, this is part 1 of space technology. Under space technology, what all things we'll be studying is, see, these are the topics we'll be covering under space technology. See, we'll be talking about ISRO and all the other organizations. Basically, we'll be talking about Indian space institutions evolution, right? Then we'll be understanding about various orbits: low Earth orbit, medium Earth orbit, geosynchronous orbit, geostationary orbit, right? Transfer orbit, right? Then polar orbit, etc. All the things we'll be studying. Then we'll be studying about satellite launch vehicles, right? All the satellite launch vehicles we'll be studying: PSLV, GSLV, GSLV Mark III, right? Next generation launch vehicle, right? Reusable launch vehicle demonstration, etc. All we'll be studying. Then we'll be studying about satellites, right? Remote sensing satellites, communication satellites, etc. Then we'll be studying about GPS, IRNSS, NAVIC, then Gagan, and we'll be studying about all the important space missions, right? Juno, right? Mars orbiter mission, right? All the space missions of NASA, ISRO, and European Space Agency, everything we'll be studying. Then we'll be studying about Exposat, Astrosat, Hubble telescope, James Webb telescope, etc. Then we'll be studying space docking experiment, SpaceX. We'll also be studying Bharati Antariksh Station, and we'll also be studying about space debris, etc. Right? So everything related to space and technology will be dealing in space technology part. Right? So first, let's go to the class notes and start with the basics. Right? Before going into space technology, first let's understand what is space. Right? See, space starts at an altitude of 100 kilometers above the surface of the earth, right? So earth's surface say 100 kilometers, right? There is a line called Karman line, right? Karman line. So 100 kilometers tak we'll be considering it as atmosphere, right? And after 100 kilometers, rest everything is space, right? Rest everything is space, right? So that is space. Now let's start with space related institutions and institutions, right? Evolution, right? First, in India, right? Space, right? With respect to space, started in 1962, right? See, उससे पहले तक individually कुछ इधर उधर researches वगैरह चल रहे थे, right? But institution started in 1962, right? Considering the importance of space in various aspects, right? How it can lead to development of the nation, right? How space technology can be used in various other sectors like agriculture, health, right? Communication, etc. Right? So in 1962, right, government has formed INCOSPAR, that is Indian National Committee for Space Research, right? In COSPAR, right? It is in COSPAR, Indian National Committee for Space Research, right? Committee is formed, right? Which is dealing with space, right? So all the decisions with respect to space and all coordination with government, this committee is doing, right? It is part of government, right? Then in 1969, right, this committee is made as ISRO, right? ISRO, Indian Space Research Organization, right? So it superseded, ISRO superseded in COSPAR, right? In 1969, ISRO is formed, right? Then in 1972, Department of Space is formed, right? Under Government of India, right? एक मिनिस्ट्री के अंदर बहुत डिपार्टमेंट्स होता है, डिपार्टमेंट ऑफ स्पेस इज फॉर्म्ड एंड इट इज अंडर द डायरेक्ट कंट्रोल ऑफ प्राइम मिनिस्टर ऑफ इंडिया, राइट? सो डिपार्टमेंट ऑफ स्पेस is formed. Now ISRO is also started functioning under Department of Space, it will be functioning as an autonomous institution. That also will be studying, right? So in 1972, Department of Space is formed. It is under direct control of Prime Minister. Then in 1992, right, Antariksh Corporation Limited is formed. Antariksh Corporation Limited. So why it is formed? See, privatization, right? Liberalization, globalization, etc. Privatization, LPG reforms happened in India, right? Now in space sector also, we have understood the importance of private players, right? So Antariksh Corporation is formed in 1992, right? It is incorporated as marketing arm of ISRO, right? So it handles ISRO's commercial deals for satellites and launch vehicles with foreign customers, right? So globalization, right? अभी इंडिया प्राइवेट सेक्टर इतना डेवलप हुआ नहीं, स्पेशली स्पेस सेक्टर में. सो अब ग्लोबलाइजेशन से हम शुरू किया, तो अंतरिक्ष कॉर्पोरेशन इज फॉर्म्ड एज ए मार्केटिंग arm of ISRO, right? It markets about various ISRO's products, right? And have commercial deals with foreign customers with respect to satellites and launch vehicles. So that is Antariksh Corporation, right? To encourage foreign deals with ISRO, right? Then next in 2019, right? See, after that, till then, Antariksh Corporation is dealing with various private sectors also and with foreign players, right? Now, with time, right, we have started realizing the importance of private sector or private players in space, right? With the kind of work the private sector is doing in other countries, especially in USA, right? With SpaceX and all, they are revolutionizing the space technology. So India also slowly started moving towards private sector, right? So with that idea, we formed New Space India Limited, NSIL, right? New Space India Limited. So it is incorporated as commercial arm of ISRO. Commercial arm of ISRO tasked with promoting and commercializing products and services from Indian space program and fostering private sector participation in space sector. One is commercializing ISRO ka products, right? And next is encouraging private sector participation in space sector. So these are the two main aims of NSIL, right? Then next in 2020, we have formed in space, right? In space, that is Indian National Space Promotion and Authorization Center, right? It is an autonomous nodal agency to facilitate private sector engagement in space activities. The agency acts as an interface between ISRO and non-governmental entities. See, this is, see, all have different purposes, sir. This is with respect to foreign customers, right? And this is with respect to commercialization and private sector participation foster करने के लिए. And in space is a basically a middleman between ISRO and non-governmental entities, that is private sector, right? So it is an autonomous agency, right? So that is with respect to in space. And next is ISPA, right? Indian Space Association, right? Indian Space Association. Indian Space Association is what? See, it is association of industrial bodies working in space, right? Association of industrial, जैसे space industry का members, they formed an association, right? So it is non-profit industry body, right? Again, this is industry body, right? Industrial members would be the members, right? Exclusively working towards exploration, collaboration and development of private and public space industry in India. See, here we need to know is, see, this is also a government institution, right? Government of India के अंदर काम करेगी, that is Department of Space. Department of Space. And this also works under Department of Space, right? Government of India. And this also works under Department of Space, Government of India. So basically, these three are government institutions, right? Right? But this is private sector, right? Private industry का association है, right? That is Indian Space Association. So association से you need to remember. So this doesn't come under Department of Space. right? So basically, industrial members, they formed an association, right, for promoting space sector in India, right? That is with respect to space. Then next is in 2023, government has bought Indian space policy, right? Indian space policy 2023. It basically does few things we'll be studying, right? So we'll be studying under Indian space policy. So first, what we need to understand here is, right, इतना ही जरूरी है, right? You don't need to go for any further research with respect to evolution, right? All important organizations and their main functions are given, right? You no need to study anything else. And one thing is, prelims में I don't think कि questions ज्यादा आएंगे इधर से, but in mains question can be asked with respect to steps taken by government of India to promote private players in space sector, right? Question can be asked for 10 marks, or they can attach some other question and they can ask. So what steps you will mention? So you will be mentioning Antrix Corporation, right, to promote private sector players only, right? Then New Space India Limited, right, to promote private sector, right? Then next is in space to promote private sector, and ISPA, right, is also for promoting private sector. And next is Indian space policy and Indian space policy ka measures to promote private sector. So these 5 points, if you mention, right, it will be very good answer, right? Good 5 solid initiatives taken by India to promote private sector, right? Now let's understand about the important thing, that is India space policy, right? Again, this is not important for prelims, but for mains, India space policy is important, right? They can directly ask India space policy, right? Highlight few key features of India space policy 2023, right? So the first is, right, so we need to understand, see, this is the policy which outlines, right, India's space for future, right? India's space sector for future, right? One of the core idea of this policy is to promote private sector participation, right? It aims to encourage and institutionalize private sector participation in India's space sector, right? So one key important, if we take from space policy, that is to encourage and institutionalize, not only encouraging, right, but also institutionalizing private sector, that is private sector hustle free decision making हो, right? प्राइवेट सेक्टर को हर्डल्स क्रिएट ना हो, राइट? किस डिपार्टमेंट से बात करना है, किस इंस्टीट्यूशन से डील करना है प्राइवेट सेक्टर को, all these things are specified in the space policy, right? With private sector participation, with ISRO primarily focusing on research and development of advanced space technology. So ISRO को basically free किया, right? Other things, right? They focusing on private sector participation in most of the things of space, so that ISRO can focus solely on R&D, research and development of advanced space technologies, right? So that is the primary goal of Indian space policy, right? Then what it did is, the policy, it sets out proper guidelines that outlines the role and responsibilities of different entities, right? Indian space policy sets out proper guidelines, right? Sets out proper guidelines that outlines the roles and responsibilities of different entities, that is Department of Space, ISRO, in space, NSIL, right? So जो भी institutions हमने डिस्कस किया, right, एंड उनका स्पेसिफिक रोल जो भी हमने डिस्कस किया, all these roles are clearly mentioned in the space policy, right? भाई तुम्हें, right, you need to coordination कौन करेगा, इसरो क्या करेगी, डिपार्टमेंट ऑफ स्पेस क्या करेगी, इन स्पेस क्या करेगी, NSIL क्या करेगी, all the things, right, are proper guidelines and outlines are made in the space with primary focus on private sector participation, right, with respect to all space activities, so that private sector can work in a hustle free environment, right? Then next, important is foreign direct investment is allowed in space sector. So in space policy 2023, it has talked in favor of foreign direct investment in space sector, and following that in 2024 government has brought up guidelines for FDI in space sector. See, private sector can participate, by Indian private companies they can participate, right, and a foreign directly they can investment, right, do investment, right. So in 2024, following the 2023 policy, government has framed guidelines for FDI in space sector, right? Space sector. Under this, up to 100% under automatic rule, right? 100% FDI, automatic rule, that is without government approval, right? You can participate in 100% FDI in manufacturing of components and systems or subsystems for satellites and ground segment and user segment, right? 100% automatic rule in manufacturing of components, right, and subsystems for satellites, ground segment and user segment, right. Components manufacture करने में, भाई मान ले कि कोई पेंट है, right, पेंट आना है तो you can 100% FDI investment, right, or say some bolts, nuts and all you need to bring, right, you can have 100% investment, right. Manufacturing of components and systems or subsystems for satellites, ground segment and user segment. Then next is up to 74% under automatic rule, up to 74% under automatic route in satellites manufacturing and operation, right. 74% tak you can automatically you can invest, no need of government approval, right. And in satellites manufacturing and operation, satellite data products and ground segment and user segment, and in this beyond 74 these activities are under government route. See here confusion है, कोई दिक्कत नहीं है, because no need to remember, right. इतना अंदर घुस के नहीं पूछेगा, but overall हमें एक broad understanding होना चाहिए, that we will be discussing. See, up to 49% under automatic rule in route in launch vehicles, associated systems and subsystems, then creation of space ports for launching and receiving spacecraft, right. So that is basically launch vehicles and space ports, that is जैसे Satish Dhawan Space Center, right, at Sriharikota, right, that is a spaceport, right. For that automatic route say 49% and beyond 49% activities are under government route. That means, so basically overall what we need to understand is, mains में इतना detailing में जाने की जरूरत नहीं है, right. Overall 100% FDI is allowed in space sector, but in few areas they need prior government approval, right. Prior government approval चाहिए, but overall government has talked in favor of 100% FDI in space sector or in majority of the areas, right. That is also under automatic route, right, not with prior government approval, right. So that is with respect to space policy, right. So basic things है, बाकी जो general points है, right, लोगों को aware करेंगे, ये करेंगे, वो करेंगे, all those generic things you can mention, right. Then let's see about the space technology, right. So that is in year 1962, INCOSPAR, that is Indian National Committee for Space Research, was formed under Dr. Sarabhai, right. Dr. Vikram Sarabhai, he played very important role, right, to formulate space program in India. On the recommendation of this committee, ISRO was formed in 1969. So ISRO basically superseded INCOSPAR, right. Then few basic facts regarding ISRO. Established in 1969, headquarters is in Bengaluru, right, and it is under administrative control of Department of Space, right. Department of Space is under the direct control of Prime Minister of India, right, and it is headed, ISRO is headed by ISRO chairman, right, who is also the secretary of Department of Space. Department of Space का भी secretary का काम करेगा, and chairman of Space Commission. So ISRO chairman is also the chairman of Space Commission, right. And what is the mandate of ISRO? As National Space Agency, development and application of space technology for various national needs is the mandate. Then ISRO built India's first indigenously developed satellite Aryabhatta, right, in 1975, but it was not launched by India. right? It was launched by Soviet Union. So first indigenously developed satellite is what? Aryabhatta, right? Aryabhatta, right? So that is India's first indigenously developed satellite in 1975. That is within 6 years we have built our first satellite and launched. उस टाइम तक लॉन्च व्हीकल सो हमने बनाया नहीं, right? So we launched by the Soviet Union vehicle, right? And in 1980, right, Rohini satellite or RS1 became the first satellite successfully launched by India using indigenously developed rocket. So that means by 1980 we have developed rocket and using that rocket we have launched Rohini satellite 1, right? After the launch in 1880 by the Indian made satellite launch vehicle SLV3 use करके launch किया. We will be studying all the launch vehicles, right? So India became the seventh country to have rocket launching capability. So seventh country, that is in 1980, right? Right. So space launching vehicles all will be studied, right? So then let's few basics with respect to satellites, right? So a satellite remains in orbit. So basically satellites are what? See, satellites are जो ये Earth है, right? Earth orbits है, right? We'll be studying all the orbits. So in the space there are orbits, right? And orbits में we have studied by जो भी objects है जिनका mass होता है, right? They create curvature in space time, right? And because of the curvature, right, there is a bend in space time and it creates gravitational force, right? Gravity create करती है, right? And gravity की वजह से जैसे अर्थ सन के सराउंडिंग घूमता है ऐसे अर्थ के सराउंडिंग मून घूमता है. लाइक मून इज ए नेचुरल सैटेलाइट. सो आर्टिफिशियल सैटेलाइट्स भी लगा के अर्थ के घूमेंगे, राइट. एंड विद दैट वी कैन डू मेनी थिंग्स विथ सैटेलाइट्स. वो भी आगे क्या करती है सैटेलाइट्स, दैट ऑल दीज थिंग्स विल बी स्टडिंग. एंड टू रोम इन द ऑर्बिट्स, राइट, टू रिवॉल्व इन द ऑर्बिट्स, राइट. सैटेलाइट्स ऐसा नहीं है कि जाके उस ऑर्बिट में रख दिया तो सैटेलाइट्स घूमेंगे, राइट. भाई सैटेलाइट्स नीड टू हैव सर्टेन स्पीड, राइट. सो दैट इज टू satellite remains in orbit because of balance between two forces. We need two forces का balance, that is satellite's velocity, that is the speed at which it is traveling in a straight line. So to remain in the orbit, satellites needs to have certain velocity, right. ऐसा नहीं है कि मान ले सैटेलाइट है वो बंद कर दिया, राइट. इफ इट इज नॉट ट्रैवलिंग इन सर्टेन स्पीड वो या तो अर्थ में गिर जाएगा या तो स्पेस से चला जाएगा, राइट. सो then there has to be satellite's velocity, right. Then there has to be the force of earth's gravitational pull on the satellites. earth का gravitational pull होना चाहिए satellites पे, right. So that is the right, ये दोनों चाहिए तभी satellite orbit में घूमेगी, right. So a satellite's orbits the earth when its speed is balanced by the pull of earth's gravity. When its speed is balanced by the earth's, अब ज्यादा स्पीड में भी जाएगी तब भी सैटेलाइट बाय ऑर्बिट से निकल जाएगी, राइट, स्पेस में चले जाएगी. और कम स्पीड में भी नहीं चलेगा. एक ऑप्टिमल स्पीड है दैट इज समवेयर बिटवीन 20,000 किलोमीटर्स, राइट. इस स्पीड में घूमना चाहिए, राइट. So without this balance, the satellite would fly in a straight line off into the space or fall back to the earth, right. Then satellites orbit the earth at different heights. All these we will be studying different speeds, right. Different speeds, ऐसा नहीं है कि जरूरत कि एक ही स्पीड में रखे, right. We will be studying जैसे लो अर्थ ऑर्बिट में, right, ये ज्यादा स्पीड में घूमेंगे, right. हायर अर्थ ऑर्बिट में कम स्पीड में घूमेंगे. एंड along different different orbits we will be studying, right. Satellites can observe large areas of earth at a time, right. ऊपर से ज्यादा एरिया देख सकते हैं, right. This enables satellites to collect more data more quickly than instruments on the ground. इसीलिए हम satellites को use करते हैं, right. Basically we will be studying earth observation satellites क्या करती है, communication satellites कैसे communicate करती है, right. So that's why we will be putting satellites also work better than telescopes, right. So इसीलिए हम टेलीस्कोप्स के ग्राउंड से टेलीस्कोप्स देखेंगे भाई, बादल वगैरह obstruct करेगा, राइट. इफ वी गो टू स्पेस विद द टेलीस्कोप एंड लुक इट फ्रॉम देयर, वी कैन सी other galaxies, other stars more properly, right? So that's the use. The reason being that satellites fly above the clouds, dust, and molecules in the atmosphere, which block the view from the ground level, right? So that is basically satellites overall will be studying, right? So will understand, right? जो भी इधर दिया हुआ है, all these things will be studying. Orbit क्या है, right? So see, now it is types of orbits, right? So types of orbits, there are different orbits, right, at different heights, right? So we'll be studying about these orbits, right? So let's go to the class page and we will study about the orbits. Now let's study about types of orbits. See, under this we'll be studying about low earth orbit, medium earth orbit, geosynchronous orbit, geostationary orbit, polar orbit, sun synchronous orbit, and geosynchronous transfer orbit, right? So let's study about one by one in detail. See, before, let's do understand basic principles. See, this is earth, right? Right, and there are many orbits, right? There are low earth orbit, medium earth orbit, based on height, right? Based on height from the earth, right? See, low earth orbit, right, it is like this, right, in low height, right? Medium earth orbit is here, right? Or there are many orbits are possible, right? Let's understand. Or say geosynchronous orbit, right, is at some 30,000 kilometers above that surface, we'll be studying, right? So this one, right? So this is about basic orbits. We'll be dealing with heights and all, and inclinations also we'll be studying. So now, if we can understand crudely, right? See, one thing we need to notice is the low Earth orbit, right? So first, let's start uh, from geosynchronous orbit. See, it is geosynchronous orbit is at a distance of some 36,000 kilometers, right? We'll be studying exact figure, right? So first, let's understand. See, geosynchronous orbit. So that means it will be at a distance from the Earth's surface, right? So when something is at a distance, right? So we can cover more area, right? We can see more of the Earth. जैसे मान ले मैं इधर से देख रहा हूं, right? Earth को low Earth orbit से, right? I can only see this much of area, right? With see, camera satellites have cameras, right? With from this small distance, we can only see this much of area, or we can cover this much of the Earth, right? Now, if we go to middle Earth orbit, see, this is low Earth orbit, right? If we go to middle Earth orbit, right? So middle Earth orbit is somewhere here, right? From here, I can see this much of Earth, right? So I can cover this much of Earth, right? ये पूरा I can cover, right? So with middle Earth orbit, right? And with geosynchronous orbit, which is at much more distance, right? I can cover nearly 1/3 of the Earth, right? So I can cover nearly 1/3 of the Earth, right? So this is geosynchronous orbit, right? This is 1/3 of the Earth I can cover, right? So that is the right coverage, right? So if I want to cover more Earth, right, I will be using geosynchronous orbit to put my satellite, right? And if I want clear picture, see, if I am at low Earth orbit, right, from here, if I take a photo, right, I can get clear pictures. So if I want clear pictures, then I will put satellites in low Earth orbit, right? And medium Earth orbit mein, if I want middle path, right, I want to cover more area, right, and also want some clear pictures, I will put my satellites in middle Earth orbit, right? And like that, other orbits also will be using, right? So this is the basic thing, right? So with from low Earth orbit, I can see clearly, right? and middle, but I can cover less area, less of Earth, right? Right? And geosynchronous orbit में, right? I can cover more of the Earth, but not clearly, right? So with this basic understanding, let's study about each of the orbits. See, first is low Earth orbit, right? So low Earth orbit, right? See, low Earth orbit is, see, this is Earth, right? So this is the low Earth orbit, right? And the low Earth orbit is relatively closer to Earth surface, right? Closer to Earth surface means low Earth orbit height or altitude, altitude is, this is from 160 kilometers to 2000 kilometers above the Earth's surface. See, Earth's surface is the orbit is, right. Earth hai. See, this is Earth, right. So orbit will be from 160, right, 160 kilometers to, say, this is 2000 kilometers, right, 2000 kilometers from the surface of Earth, right. Any orbit, right, we can make any number of orbits, right. These will be called as low Earth orbit. See, 500 kilometers में भी कुछ रख दिया, right. 560 kilometers, right, say 760 kilometers above the Earth surface. If I put a satellite, that will be a low Earth orbit, right, low Earth orbit. And since the height is low, right, the gravitational pull is more, right, because we have studied the greater the distance, the less will be the gravitational force, right. So or even the orbit it revolve, or orbit it rotates. See, अब देखो इधर है, see, orbit भी कम, राइट, अगर इधर है तो इतना बड़ा ट्रैवल करना पड़ेगा, राइट. सो सिंस इट इज नियर टू अर्थ, लो अर्थ ऑर्बिट, so satellites takes less time, right, less time to complete a revolution around the earth, right, or to cover the earth. So time it takes is, time for a satellite which put in low earth orbit to orbit the earth is 90 minutes, 90 minutes or 1.5 hour, right. So 1.5 hour or 90 minutes, right. So we'll see कैसे मीडियम अर्थ ऑर्बिट और हाई अर्थ ऑर्बिट और जियोसिंक्रोनस ऑर्बिट में क्या टाइम कैसे वेरी होता है, राइट. देन नाउ वी नो, सी, आई हैव टोल्ड यू, राइट, जैसे ये लो अर्थ ऑर्बिट है, अर्थ के पास है, राइट, एंड अर्थ के पास है तो आई कैन टेक क्लियर पिक्चर्स, राइट. सो मान ले मैं एक आई हैव सेंड ए remote sensing satellite, right, remote sensing satellite which can take pictures of the earth, right. Pictures of the remote sensing में mostly भाई कैमरा होती है, पिक्चर वगैरह लेते हैं, right, और अर्थ को सेंस करते हैं, right. So if I want to take picture of earth, right, since it is in low earth orbit, I can take clear pictures, right, I can take high resolution images, right, high resolution images, right. And also low delay, agar communication satellite, if I put it, low delay in communication, right. See, communication में क्या होता है, right, generally मान ले सैटेलाइट है इधर 160 altitude में, right. So from earth we communicate to satellite and from satellite we will again get the communication back. So since low earth orbit है, ज्यादा distance travel करना नहीं है, so there will be less delay in communication, right, and there will be high resolution of images. So that's make the low earth orbits का advantages है ये. These are the advantages of low earth orbit. And but negative भी है, disadvantages भी है, right. That is, since the orbit, इस orbit में gravity ज्यादा है, so satellites will be moving at high speed, right. So satellites will be moving at high speed, right, and atmosphere भी present होता है, right, and there is a drag, atmospheric drag, right. So because of that, the satellites are shorter lifespan, shorter lifespan होता है satellites पे, right. And one other disadvantage is we have seen जितना पास है तो लिमिटेड कवरेज ऑफ अर्थ सो कंप्लीट अर्थ को कवर करना है सो वी नीड मल्टीपल सैटेलाइट्स सो अनदर डिसएडवांटेज इज लिमिटेड लिमिटेड कवरेज coverage of earth and we need more satellites to see entire earth right so that's what we have seen see low earth orbit में लो अर्थ ऑर्बिट ठीक है लो अर्थ ऑर्बिट कवर्स वेरी लेस अर्थ राइट सो अगर पूरा अर्थ को कवर करना है सो वी नीड टू पुट मोर सैटेलाइट्स राइट ये इतना एरिया कवर करेगी राइट सो वी नीड टू पुट मोर सैटेलाइट सो दैट इज द ड्रॉबैक विथ रेस्पेक्ट टू लो अर्थ ऑर्बिट राइट सो and again one example see all these things are mentioned in the notes right so you can just simply read and understand पहले चीजें समझने की कोशिश करो then you can easily revise it from the notes so example of low earth orbit is Indian space international space station right international space station है low earth orbit में है right this about international space station also we'll be studying right then let's study about medium earth orbit right so medium earth orbit right again altitude is what altitude is from earth the distance of the orbit is from 2000 kilometers right to 2000 kilometers to 3500 kilometers sorry 35000 right 2000 kilometers to 35780 kilometers they are considered as medium earth orbit right medium earth orbit is from earth surface इस डिस्टेंस में कोई भी ऑर्बिट हो तो दैट इज कंसिडर्ड एज मीडियम अर्थ ऑर्बिट राइट एंड सिंस मीडियम अर्थ ऑर्बिट है मिडिल में है राइट सो मिडिल में सो टाइम फॉर वन ऑर्बिट इट टेक्स इज बिटवीन 2 hours टू 24 hours 2 hours to 24 hours right so हमने देखा भाई लो अर्थ ऑर्बिट के लिए भाई सी अर्थ इज दिस वन right low earth orbit is here right for low earth orbit it will take 90 minutes right on average we are doing right it also varies from distance right so and medium earth orbit में भाई 2000 किलोमीटर से ज्यादा है so it will take more time जैसे जैसे distance बढ़ेगा जैसे जैसे 2 hours to 24 hours जैसे हम लोग if we go to 35,780 kilometers it will take 24 hours 24 hours what we will be studying right abhi have patience right while we study geosynchronous and geostationary right we will say by the exact distance at which these satellites stand and it will take 24 hours right so then advantage right since they are far away from earth right जैसे low earth orbit से far है so advantage is they can cover larger area and also have longer lifespan right longer lifespan right longer lifespan compared to all these are compared to low earth orbit satellites say right compared to low earth orbit satellites right however disadvantages are right however satellites in medium earth orbits experience higher communication delay right higher communication delay because भाई ज्यादा टाइम है राइट जैसे मान ले मीडियम अर्थ ऑर्बिट इधर है राइट पहले इधर आएगा फिर इधर जाएगा सो इट विल टेक टाइम सो देयर विल बी डिले इन कम्युनिकेशन जैसे फोन राइट फोन कॉल्स राइट इफ यू आर यूजिंग मीडियम अर्थ सो फोन कॉल्स में डिले होगा इंटरनेट वॉइस ओवर कॉल्स में डिले होगा राइट एंड डिले राइट ड्यू टू इंक्रीज डिस्टेंस एंड एग्जाम्पल ऑफ some satellites in medium earth orbit is GPS right जो GPS है ग्लोबल पोजिशनिंग सिस्टम ऑफ यूएसए इसके बारे में भी वी विल बी स्टडिंग राइट इट इज इन मीडियम अर्थ ऑर्बिट राइट वो क्यों मीडियम अर्थ ऑर्बिट में वी विल बी डिस्कसिंग व्हाइल डिस्कसिंग GPS right so that is with respect to medium earth orbit then next let's go and study about geosynchronous orbit and geostationary orbit right see geosynchronous orbit and geostationary orbit see geosynchronous means what synchronous means synchronous right there is some synchronity right synchronous that is with respect to revolution of or satellite, right, is equal to rotation of earth, right. So क्या है, हम समझेंगे. See, geosynchronous, first let's study about altitude, right. See, geosynchronous orbit altitude is at 35,786 kilometers above the surface of earth. See, this one, this is, this distance is, orbit ka distance is at a altitude. See, earth is like this, earth, and at 35,786 kilometers away from earth, right, the orbit is called as geosynchronous orbit. See, this one is geosynchronous, right. Same geosynchronous जैसे geostationary भी होते हैं, right. So वो भी पढ़ेंगे, right. At altitude of 35,786 kilometers is geostationary orbit. अब इस हाइट में क्या होता है, एग्जैक्ट इस हाइट में क्या होता है, से ए satellite is revolving. See, this one is a satellite, right. So satellite जैसे मूव करेगा, right, satellites will be moving in this orbit. This is geosynchronous orbit, right. Geosynchronous orbit, right. Satellite move हो रहा है, and जैसे जैसे satellite move होता है तो earth भी rotate होता है. So earth rotation of earth will take 23 hours 56 minutes 4 seconds, right. And revolution of the satellite, एक राउंड मारने में भी सैटेलाइट कितना टाइम लेगा, that is 23 hours 56 minutes 4 seconds, right. So that's why it is geosynchronous. Synchronous, the orbit is synchronous with the earth, synchronous with the earth's rotation, right. So that means एक ऑर्बिट में सैटेलाइट घूमने में it will take 1 day, or similar to the rotation of the earth. So that's why it is called geosynchronous. जैसे हमने देखा, see, जैसे जैसे हाइट बढ़ेगा वैसे वैसे टाइम बढ़ेगा, राइट, बिकॉज ऑर्बिट का लेंथ बढ़ेगा, ग्रेविटी कम होगा, राइट. एट दिस हाइट, ठीक है, जियोसिंक्रोनस होता है. सो दैट व्हाई इट इज कॉल्ड जियोसिंक्रोनस ऑर्बिट, राइट. जियोसिंक्रोनस ऑर्बिट, राइट. अब ये क्या है, दिस ऑर्बिट, राइट, दे आर इंपॉर्टेंट फॉर रिमोट सेंसिंग, राइट. रिमोट सेंसिंग, राइट, particularly useful in telecommunications and remote sensing. वो कैसे, we will be understanding, right. First let's understand geosynchronous. तो देख लिया. अब geosynchronous orbit is, right, any orbit, right. जैसे मान ले ऐसा एक ऑर्बिट है, right, अर्थ का, right, at 35,786 kilometers. That is also, so there are many possibilities, many possible orbits, right. geosynchronous orbit कोई भी ऑर्बिट हो सकता है, right. See, अर्थ का इतना ऑर्बिट्स, right, any n number of orbits are there which are geosynchronous at height of, जैसे अर्थ का एक ऑर्बिट ऐसा होगा, right, एक ऑर्बिट ऐसा होगा, right. So many, but the orbit which is at parallel to the 0 degree, parallel to equator, right, at a height of 35,786 kilometers, वो ये की होगा. So that is geostationary orbit. geostationary orbit, see, that is, see, equator है, right, equator पे है, right, equator पे ही घूमेगा, right. So that is geostationary orbit. That is, अगर कोई equator पे खड़ा है, right, अब अर्थ भी इस साइड घूम रही है, right, अब सैटेलाइट भी इक्वेटर पे ही घूमेगी, right. So if one is observing, if a person is standing here, right, and observe that satellite, for him it seems stationary, right, क्योंकि अर्थ भी घूम रही है, सैटेलाइट भी सेम घूम रही है. So geostationary, so there is only one possible orbit, right. So that is geostationary orbit is nothing but geosynchronous orbit, right, geosynchronous orbit at the equator of the earth, that is geostationary orbit, right. ताकि इक्वेटर में जो पर्सन खड़ा होगा उसके लिए सेम दिखेगा. भाई बाकी है वो ऐसा घूमेंगे, राइट, बाकी ऑर्बिट से कुछ एंगल डिफरेंस होगा, राइट, बट जो ये के ये एक ही हो सकता है, जियो स्टेशनरी ऑर्बिट, राइट, एंड जियो स्टेशनरी orbit also will be using for specific purposes, right, and as earth revolves from west to east, right, so orbits भी इसमें भी satellites ऐसा ही घूमेंगे, right, so that is with respect to geostationary orbit and geosynchronous orbit, right. So now let's study about the next orbit, that is polar orbit. See, we will be studying नोट्स ऑल्सो, नोट्स में भी जो भी पॉइंट्स है वो भी सब डिस्कस करेंगे दोबारा, राइट, दैट विल बी रिविजन लाइक ऑफ ए थिंग फॉर यू ऑल्सो, राइट. फर्स्ट लेट्स अंडरस्टैंड बेसिक्स, देन नेक्स्ट इज पोलर ऑर्बिट, राइट. पोलर ऑर्बिट इज, सी, ज्यादा सी, अब जियो सिंक्रोनस है वो भाई ऐसा भी घूम रहे थे, राइट, जियो स्टेशनरी तो पैरेलल टू इक्वेटर, जियो सिंक्रोनस like this, right, there are n number of orbits, but polar orbits are what? Orbits, polar orbits are orbits which are pole centric, that is poles में तो जाएंगे जाएंगे, अर्थ का नॉर्थ पोल एंड अर्थ का साउथ पोल, राइट. सो ऑर्बिट्स एंड दे आर बेसिकली लो अर्थ ऑर्बिट्स है, लो अर्थ ऑर्बिट्स, दैट इज फ्रॉम हाइट 160 किलोमीटर टू 2000 किलोमीटर्स हाइट है, राइट, एंड they are they move mostly from pole to pole, right, polar areas को cover करते हैं, right, that is polar orbits are, right, orbit that travels north south over the poles, right, north south over the poles, right, and right, north south over the poles, and it is at a height of लो अर्थ ऑर्बिट के हाइट में 160 किलोमीटर टू 2000 किलोमीटर हाइट में, राइट, एंड पोलर ऑर्बिट्स हैव एन इंक्लिनेशन ऑफ अबाउट 90 डिग्रीज टू इक्वेटर. सी, इक्वेटर ऐसा है, सो पोलर ऑर्बिट्स ऐसा है, सो बाई एटलीस्ट 90 डिग्रीज, एग्जैक्ट नहीं है, ऑलमोस्ट 90 डिग्रीज, बिकॉज पोल्स से वो घूमना है, राइट, राइट. सो दिस इज द पोलर ऑर्बिट्स, राइट, एंड पोलर ऑर्बिट्स का खासियत क्या है? सी, दे आर यूज्ड इन अर्थ ऑब्जर्वेशन, सी, एंड इट टेक्स पोलर ऑर्बिट्स, सिंस ये लो अर्थ ऑर्बिट में है, एंड लो अर्थ ऑर्बिट में एक ऑर्बिट घूमने के लिए सैटेलाइट कितना टाइम लेगा? दैट वी नो, दैट इज 90 मिनट्स, राइट. सो दैट मींस इन एवरी 90 मिनट्स, राइट, इन एवरी 90 मिनट्स दिस सैटेलाइट विल बी मेकिंग वन रोटेशन, राइट, इन एवरी 90 मिनट्स इट विल बी कमिंग टू, सो अर्थ भी घूमेगा ऐसा, राइट. सो इन फर्स्ट 90 मिनट्स जो भी polar area, जैसे earth is also rotating, so once it observes this area and another 90 minutes it observes this area and another 90 minutes it observes this area, so within a time span of few days it will be observing the same area again, right. So for that it can show any changes in the area, right. जैसे मान ले ice cap है, right, ओवर एक साल में इस ice cap के ऊपर बहुत बार आएगा पोलर ऑर्बिट में सैटेलाइट, राइट. सो अगर मान ले आइस कम हो गया, राइट, स्नो मेल्ट हो गया, राइट, सो आइस दिस पोलर ऑर्बिट कैन ऑब्जर्व, राइट. सो दैट इज द यूज, राइट, वी विल बी डिस्कसिंग मोर अबाउट इट, राइट. फर्स्ट लेट्स अंडरस्टैंड द बेसिक्स, देन नेक्स्ट इज सन सिंक्रोनस ऑर्बिट, राइट. सन सिंक्रोनस ऑर्बिट, what is sun synchronous orbit? Sun synchronous orbit is a type of polar orbit with some inclination, right. See, ये है, सी, पोलर ऑर्बिट, पोल से पोल घूमेगा, राइट. सन सिंक्रोनस ऑर्बिट है, पोलर ऑर्बिट ही है, राइट, बट सम इंक्लिनेशन, राइट, सम 6 डिग्रीज 8 डिग्रीज 10 डिग्रीज इंक्लिनेशन, राइट. अब इंक्लिनेशन क्यों है, राइट, व्हाई द इंक्लिनेशन इज देयर? इट इज बिकॉज इंक्लिनेशन इज देयर बिकॉज सो दैट देयर इज सन, राइट, इट इज सिंक्रोनस विथ द सन्स मूवमेंट, सो दैट जो भी जब भी सैटेलाइट आएगी एक पोजीशन में, भाई उधर सनलाइट प्रेजेंट होगा, राइट, और सन भी साथ होगा. सो दिस सैटेलाइट्स विच आर सिंक्रोनाइज्ड विथ सन्स मूवमेंट, दे आर कॉल्ड सन सिंक्रोनस ऑर्बिट, राइट. सो सन सिंक्रोनस ऑर्बिट, एंड अगेन पोलर ऑर्बिट ही है. सो पोलर ऑर्बिट एल्टीट्यूड इज व्हाट? एल्टीट्यूड इज 160 किलोमीटर्स टू 2000 kilometers, right, and time it will take by same low earth orbit time, it will take 90 minutes, right? And what is a special feature of sun synchronous orbit is it passes over any given point on earth surface at the same local solar time, right? जैसे मान ले इस पॉइंट है, right? So say this point on earth, right? Say this point on earth, say this point, right? Any point on earth, it passes over any given point on earth surface surface at the same local solar time, right? सन जैसे जाएगी वैसे सेम लोकल सोलर टाइम पे जाएगी, राइट? जैसे कुछ भी चेंजेस आया उस टाइम पे इट कैन ऑब्जर्व एंड वी कैन notice changes, right? That is with respect to sun synchronous orbit, right? So there is a video also, small video with respect to sun synchronous orbit. You can also watch this, you will get more clarity, right? So now let's see.
सन सिंक्रोनस ऑर्बिट क्या होते हैं? ये एक प्रकार के पोलर ऑर्बिट होते हैं। पोलर ऑर्बिट एक प्रकार के लो अर्थ ऑर्बिट होते हैं। तो एसएसओ ऑर्बिट और पोलर ऑर्बिट जरूरी नहीं है कि पोल्स के ऊपर से गुजरे। अगर पोल से 20 से 30 डिग्री का डेविएशन है तो भी आप उनको पोलर ऑर्बिट बोल सकते हो। बेसिकली इन ऑर्बिट्स में जो सैटेलाइट हैं वो पोल के इलाके को ज्यादा मॉनिटर करते हैं। अब सन सिंक्रोनस ऑर्बिट होने का क्या लॉजिक है? लॉजिक ये है कि इन ऑर्बिट्स में जो सैटेलाइट्स हैं वो सिंक्रोनस होती हैं विद सन, मतलब इनकी एक फिक्स्ड पोजीशन होती है रिलेटेड टू द सन। प्रैक्टिकल टर्म्स में समझें तो मान लीजिए रशिया के मुर्मांस्क रीजन के ऊपर कोई सैटेलाइट दिन के 2 बजे पहुंच रहा है तो अगले दिन भी वो वहां पे 2 बजे ही पहुंचेगा। तो इससे क्या होता है, लॉन्ग रेंज मॉनिटरिंग जैसे कि हफ्तों की महीनों की मॉनिटरिंग बहुत सिंक्रोनाइज हो जाती है। तो अगर आप सी लेवल राइज को मॉनिटर कर रहे हो, फ्लडिंग को मॉनिटर कर रहे हो, फॉरेस्ट फायर को मॉनिटर कर रहे हो, इससे रिलेटेड डाटा को अक्यूमुलेट कर रहे हो, लोकल टोपोग्राफिकल चेंजेस को चेक कर रहे हो।
Now see, you have watched the video. Now let's see sun synchronous orbit, other orbit, that is geosynchronous transfer orbit, right? Again, this is very important orbit and very important to understand this, right? See, geosynchronous transfer orbit, right? See, geostationary orbit or for that matter any orbit में हमें सैटेलाइट छोड़ना है, राइट? फॉर हायर अर्थ ऑर्बिट, राइट? जैसे मान ले सी दिस इज अर्थ, राइट? एंड जियो ट्रांसफर ऑर्बिट और GTO is an elliptical orbit, right? It is not a circular orbit, right? So this orbit will be like this. This orbit is like this, right? So this orbit is like this. So what is this is, see, or इधर भी होगा orbit तो, right? For our convenience, right? So this orbit is, see, here the distance from earth is, see, here it is 800 to 1000 kilometers, right? And from here the distance is, this distance is 35,786 kilometers, right? So from this side earth से distance होगा 35,786 and here the distance is of this orbit is, right, 800 to 1000 kilometers, right? अब what is the use of this is, see, we need to send any satellite to geostationary orbit or geosynchronous orbit, right? So let's take a geostationary orbit, right? So geostationary orbit, right? Geostationary orbit, see, 35,786 kilometers and east side also 35,786 kilometers, right? So this is the geostationary orbit, right? Now see, अगर सैटेलाइट को इस साइड सीधा इधर से भेजना है, सो वी नीड टू सेंड सैटेलाइट फॉर 35,000, कहीं भी भेजना है, राइट? वी नीड टू सेंड इट फॉर 35,786 किलोमीटर्स, राइट? ऑर्बिट में भेजना है, राइट? 35,700 कोई भी, राइट? फ्रॉम अर्थ सरफेस से डिस्टेंस होगा 35,786 किलोमीटर, राइट। उसके लिए ज्यादा फ्यूल लगेगा, राइट, ज्यादा एनर्जी लगेगा, राइट, ज्यादा पैसा लगेगा, राइट। सो जियो स्टेशनरी ट्रांसमिट क्या करती है, राइट, it will, right, we can, rather than sending it to 35,786 kilometers, we can send a satellite to 8,000 kilometers, right, and either 1,000 to 800 kilometers, then we can send it to here, and from here we can push into geostationary orbit, right. So satellites will be pushed. So satellites, so basically synchronous transfer orbit, what does it do? It provides a temporary parking spot for satellites, right. So जब जब है इधर पार्क करो, जियो ट्रांसफर ऑर्बिट में पार्क करो, राइट, व्हेन देयर इज नीड they just give a push and push it to the geostationary orbit, right. Or say for interstellar missions, right, interplanetary missions, right, दूसरे planet पे भेजना है, जूनो, राइट, जुपिटर में, सैटर्न में, मार्स में, कुछ भी कहीं भी भेजना है, राइट, rather than sending it to geostationary orbit or directly to outer space, right, outer space पे तो और आएगा, right. So first send it to geo GTO, right, and GTO 800 किलोमीटर पे फिर पुश करो, राइट, इधर आएगा फिर वापस आएगी, राइट, देन इधर 800 किलोमीटर में फिर पुश करो, फिर जाएगी, फिर वापस आएगी, देन अगेन पुश इट with greater thrust, so then it will move outside the earth's sphere of influence, right. So that is the main role of geosynchronous transfer orbit, that is temporary parking spot for satellites which can be put in geostationary orbit, right, or interplanetary missions. और जब कंडीशंस फेवरेबल हो और विथ ज्यादा पुश से अच्छा दूर जा सकता है, राइट, देन यू कैन पुश इट. So basically geosynchronous transfer orbit is a temporary parking spot for the satellites which can be put, right. So with this we are done with the all the orbits, right. So let's go to the nodes and study what is there, and nodes में comprehensively एक एक point को हम समझेंगे, right. See, we have understood basics of orbits, right, types of orbits. So now let's read the content, right, so that we will understand better, right. So that's why, see, what I am doing in classes is I am explaining you concepts, then notes में each and every word given in the notes we are trying to understand, right. So आपको एक एक चीज अच्छे से समझ में आएगा, right, so that you can keep on revising the notes, right. That's why I am also providing notes, and जो चीजें सीधा note से directly समझ सकते हैं, right, that also we are doing it, right. See, low earth orbit, right, an orbit that is relatively close to earth's surface is low earth orbit. Orbit at an altitude of 160 kilometers to 2000 kilometers from the surface of earth, right. Satellites in low earth orbit orbit around the earth in 90 minutes. So we have discussed it, right. Low earth orbit में कम time लेगा, around 90 minutes. Hence these are used in weather monitoring, earth observation and communication, right. Earth observation में भाई कम distance में earth observation में we can take good pictures, right. वो satellites में भी हम लोग समझ लेंगे, right. And weather monitoring, we can monitor weather, and communication में there is less delay in communication, right. So उन satellites के लिए use कर सकते हैं. Since they are near to earth, they can take high resolution images of earth ले सकते हैं, right. Then low delay in communication, right. So satellites in low earth orbit have shorter lifespan due to atmospheric drag, shorter lifespan, or must be repositioned often. So shorter lifespan है तो repositioned often, right, and limited coverage of earth, right. We have understood, जैसे कम low earth orbit इधर है तो भाई we can cover only less area of earth, right. Example of is International Space Station, right? International Space Station. Then next is medium Earth orbit, right? Medium Earth orbit, right? That is orbit at an altitude from 2000 kilometers to 35,780 kilometers. 2000 kilometers to 35,780 kilometers from the surface of Earth, right? Medium Earth orbit, right? Satellites in medium Earth orbit around the Earth in between 2 hours to 24 hours. We have studied, right? Since they are far away from Earth, they can cover larger area and also have longer lifespan compared to low Earth orbit. Have longer lifespan compared to low Earth orbit. However, satellites in medium Earth orbit experience higher communication delay compared to low Earth orbit satellites due to increased distance. Right? Higher communication delay. Right? Right? We have understood it. Then geosynchronous or geostationary orbit. Right? Yeah, important है. So this, right, we will be understanding. See, geosynchronous orbit synchronizes with the rotation of the Earth. Right? Synchronize with the rotation of the Earth. Both happens at 23 hours. More specifically, the time it takes for the Earth to rotate on its axis is 23 hours, 56 minutes and 4 seconds, which is same as the satellites take to complete one geosynchronous orbit, right? That's why they are called geosynchronous, synchronous with the Earth, right? Then it is an orbit at an altitude of 35,786 kilometers above the Earth's surface. Satellites in geosynchronous orbit are particularly useful for telecommunication and remote sensing applications. See, yeah, these things we'll be understanding while studying about satellites, right? ये इसी टॉपिक में पढ़ेंगे, right? We'll get better understanding, right? Then geostationary orbit. See, geostationary orbit is a kind of geosynchronous orbit, right? Kind of geostationary orbit, geosynchronous orbit है, but equator पे, right? Geostationary orbit is also called as geosynchronous equatorial orbit, right? Geosynchronous orbit which is at the equator of the Earth, that is geostationary orbit, as it is a synchronous orbit above Earth's equator, right? So satellites in geostationary orbit circle Earth above the equator from west to east following Earth's rotation. See, Earth also rotates from west to east. We study it in geography, right? Similarly, geostationary orbit में भी जो satellites होते हैं वो भी west to east घूमते हैं, right? So and this makes satellites in geostationary orbit appear to be stationary over a fixed position. मैं अभी equator में खड़ा रहूंगा, एक geostationary orbit मेरे सिर पे खड़ा होगा, तो वो हमेशा मेरे सर पे ही खड़ा होगा, right? As Earth moves, that satellite also revolves, right? So geostationary orbit is an orbit at an altitude of 35,786 kilometers above Earth's equator. Thus, there is only one geostationary orbit. So एक ही है भाई, equator है, right? Equator पे एक ही है, right? एक ही orbit है, right? So there is only one geostationary orbit. Scientists have altered the world scientists have alerted the world about the possible dangerous collision events as the satellites are crowding at the Earth's geostationary orbit. By geostationary orbit में, right, there are only one orbit is there, right? And many satellites are being sent, right? Because वो telecommunication जो DTH services है, right? जैसे टाटा डिजिटल स्काई, right? And all they are placed in geostationary orbit, right? So that's why there are many satellites, उन पे crowd हो सकता है, right? Then geostationary orbit is disadvantaged for certain types of services such as voice calls and video conferences because of time delay, because of relatively large time delay, because distance ज्यादा है, right? Because of 0.25 seconds delay होता है, right? Experienced by a communication signal in traveling from Earth to a geostationary satellite and back. See, जैसे मान ले Earth है, right? So geostationary orbit है equator पे, right? Say that is at 35,000 some kilometers, right? अब communication में if I am using it, see, first satellite is there. See, Earth से if communication में what happens, right? See, I am communicating, right, to satellite, and from satellite it needs to get to you, right? So if it is there at such long distances, it will take more time to go back there and again get back to you, right? So that is some 0.25 seconds delay होगा, right? 1/4 of the second delay होगा, right? So उसको बचाने के लिए, जैसे वॉइस कॉल्स है, राइट, कॉल्स में, वीडियो कॉन्फ्रेंसेस में वो काम नहीं करेगा, सो उसके लिए, उनके लिए विल बी यूजिंग लो अर्थ ऑर्बिट, राइट? बट अदर देन दैट, जहां टाइम डिले का इश्यू नहीं है, जैसे टीवी, टेलीविजन, राइट, टेलीविजन चैनल्स में टाइम डिले का इश्यू नहीं है, सो दैट्स व्हाई they are, for this reason, geo systems are best utilized where time delay is not an issue, as is the case of direct TV service, DTH services, and internet data services. इंटरनेट डेटा सर्विसेज में भी अगर भाई डेटा है, स्पीड चाहिए हमें, राइट, बट उसमें डेटा ट्रांसफर वगैरह में 0.25 सेकंड डिले तो नहीं होगा, तो इसीलिए इनके लिए डीटीएच. सो इसीलिए जैसे इफ यू सी द डीटीएच, राइट, जैसे टाटा स्काई वगैरह जो भी घर पे लगते हैं, राइट, दे आर पॉइंटेड टुवर्ड्स इक्वेटर, राइट, ऑब्जर्व करना, हमेशा इक्वेटर की तरफ पॉइंट होगा, राइट, जैसे हम लोग नॉर्थन हेमिस्फीयर में, राइट, दे आर पॉइंटेड टुवर्ड्स द सन, राइट, एंड सदर्न हेमिस्फीयर में तो वो ऑपोजिट डायरेक्शन में होगा, राइट? सो दैट्स व्हाई, बिकॉज दे आर इन जियो स्टेशनरी ऑर्बिट, राइट? डीटीएच सर्विसेज है वो, राइट, वी विल बी स्टडीइंग इन सैटेलाइट्स आल्सो दिस, राइट? सो GEO is used by satellites that need to stay constantly above one particular place over Earth, such as telecommunication satellites. So this way, an antenna on Earth can be fixed to always stay pointed towards that satellite without moving, right? So it can also be used by weather monitoring satellites because they can continuously observe specific areas to see how weather trends emerge there, right? So that is the geosynchronous and geostationary orbit, right? The next is polar orbit, right? So polar orbit travels north side south over the poles. The poles में करेंगे, right? Poles are here, right? So north south over the poles, and it takes approximately hour and half for a full rotation, right? Because low earth orbit में होते हैं, polar orbits are nothing but low earth orbits है, right? And the satellite is in orbit, the earth is rotating beneath it, right? Rotating satellites orbit में earth भी rotate कर रही है. As a result, a satellite can observe the entire earth's surface in the time span of 24 hours, right? In a time span of 24 hours, the satellite can observe entire earth's surface. So polar orbits have an inclination of about 90 degrees to the equator, right? So almost all the satellites that are in polar orbit are at lower altitude or low earth orbit. Low earth orbit 160 kilometers to 2000 kilometers, right? So that's why they take 90 minutes only. So they are often used for applications such as remote sensing by low earth orbit पे, right? Remote sensing में photos, right? Remote sensing क्या होती है, all these things we will be discussing. जो भी satellites related है अभी थोड़ा lightly जाओ, because we will be discussing on satellites topic, and monitoring crops, forests, and even global security, right? So satellites in polar orbits monitor Earth's surface including ice caps, forests, crop sea. दिन में एक बार पूरा अर्थ को एक बार देखती है, राइट? आइस कैप्स है भाई, दिन भर कैसे चेंज हो रहा है, फॉरेस्ट से, फॉरेस्ट फाइल्स वगैरह हो रहा है, कल नहीं हुआ था, आज हो रहा है, राइट? फॉरेस्ट में कब, इस महीने में कितना फॉरेस्ट कवर थी, राइट? समर में कितना फॉरेस्ट कवर थी, एंड ऑल वी कैन कवर. क्रॉप्स, दे आल्सो यूज्ड इन एनवायरमेंटल मॉनिटरिंग टू ट्रैक पोल्यूशन, राइट? Pollution, Delhi में it can pass over Delhi every day, right? So it can track pollution, it can track deforestation, and it can track changes in the polar regions, right? Because poles में है, right? Then next is sun synchronous orbit, right? So sun synchronous orbit is a type of polar orbit, right? Type of polar orbit with some inclination. When a satellite is in sun synchronous orbit, it means that it has a constant sun illumination through inclination and altitude. So consistent sun illumination होता है, right? For sun synchronous orbits, it passes over any given point on Earth's surface at the same local solar time, right? Same local solar time पे pass करेगी, right? Because of the consistent lighting in the sun synchronous orbit, scientists leverage this in various remote sensing applications. They are also used for climate studies and environmental monitoring with high precision, right? See, ये वाला पार्ट है सैटेलाइट्स वाला पार्ट, विल बी डिस्कसिंग, उधर आपको और क्लैरिटी मिल जाएगा, राइट। विल बी डिस्कसिंग जियो रिमोट सेंसिंग क्या होता है, अर्थ ऑब्जर्वेशन क्या होती है, राइट, कम्युनिकेशन सैटेलाइट्स क्या है, वेयर वी यूज एंड ऑल विल बी डिस्कसिंग, नो नीड टू वरी, राइट। देन नेक्स्ट इज जियोसिंक्रोनस ट्रांसफर ऑर्बिट, राइट। जियोसिंक्रोनस ट्रांसफर ऑर्बिट is called as temporary parking spot and used for satellites launched into geostationary orbit and interplanetary missions. So we have discussed GTO ये है, right? So instead of launching into a 35,000 kilometers, right, we can use the 800 to 1000 kilometers GTO, right? And from here we can move in the orbit of, right, when we can push it to the geostationary orbit or we can push it to the interplanetary missions, right. So this is temporary parking spot, geosynchronous transfer orbit, right. Geosynchronous and geostationary orbits पे transfer कर सकता है by using GTO, right. So, right, so that's it. So next, so this also we have understood, right, coverage कितना करती है, right. So now we will be studying ISRO's satellite launch vehicles. See, now let's study about ISRO's satellite launch vehicles. See, we have seen satellites को orbit में रखना है, right. How to put those satellites in orbits, right. We will be using satellite launch vehicles to put our satellites into the orbits, into low earth orbit, medium earth orbit, geostationary, geosynchronous, etc, etc, right. So ISRO uses following satellite launch vehicles. So they are SLV, ASLV, PSLV, GSLV and GSLV MK3, right. So these are currently used. See, currently used nahi hai, mostly used. See, these two are not in current use, right. The initial satellite launch vehicles, right, and these three are presently used, right, and these four are in development stage, right. ISRO is developing them, that is SSLV, RLVTD, scramjet and NGLV, right. We'll be studying about all these satellite launch vehicles. See, first let's start with SLV, right. See, SLV, right, that is satellite launch vehicle, right, satellite launch vehicle. See, we have read that first satellite we launched, that is ISRO launched, is Rohini, right. Rohini satellite, right, we launched, right. This satellite launch vehicle, right, was used, and that is SLV3 was used, right. So this is SLV3, right. So SLV3 is the first satellite developed in year 1980, right, 1980, right. What is this? This is a four stage four stage four stage satellite, and all the four stages have all solid fuel, right, solid fuel. So now let's understand ki what is the solid fuel, right, or fuel. See, satellites, by satellites are vehicles, right. ऊपर मूव करना है जैसे अपने कार और बाइक के लिए पेट्रोल डीजल लगता है, राइट, वैसे ही rockets है, satellite launch vehicles are rockets, right. To move them we need fuel, right, and the fuel which we use is solid, right, solid fuel, right. There are four stages, right. Four stages क्यों होता है, that also we will understand, right. See, say this is first stage, right, this is second stage, this is third stage and this is fourth stage, right. And इसमें भी होगा solid fuel and इसमें भी solid fuel, right, solid fuel and solid fuel, right, all four stages. See, use this stage for some time, right, and after that this will be left out, right. So थोड़ा weight कम हो जाएगा, right, and next this soil will be used, right, this fuel will be used and then this will be left over, after some traveling some certain height, and after this fuel will be used and this will be left over, right? And this will be used, and when this contains payload, right? So payload जो भी satellite है, right? The satellite will be in this part of the rocket, right? जो उसको orbit में रखेगा. So SLV, its capacity is 40 kg payload. 40 kg payload, right? 40 kg का satellite ही orbit में रख सकती है, and that too also in low earth orbit. Low earth orbit, right? Low earth orbit is height of 160 kilometers to 2000 kilometers, right, from the surface of earth, right? उतना ही distance लेके 40 kg, 40 kg payload, that is very less payload, right? So that is the capacity of SLV3, right? Right? So Rohini satellite or RS1 is launched with SLV3 satellite, right? So then payload तो काफी कम है, right? So we need to improve it. So ISRO has worked and then it has come up with ASLV, right? Next is ASLV, right? See, this is ASLV, that is augmented satellite launch vehicle. Augmented version of SLV. SLV का ही augmented version है, right? And it is successfully launched in 1992. 1992 में successfully launched, and it is a five stage all solid. जो फ्यूल है वो सॉलिड फ्यूल है, राइट? बिकॉज सॉलिड इज व्हाट? सॉलिड फ्यूल इज इजी टू कैरी, राइट? कोई लीकेज वगैरह नहीं होगा, राइट? एंड बर्निंग के लिए ऑक्सीडाइजर, लिक्विड फ्यूल में क्या होता है, क्रायोजेनिक फ्यूल में क्या होता है, वी विल बी स्टडीइंग इन सब्सिक्वेंट स्टेजेस, राइट? सॉलिड फ्यूल इज इजी टू कैरी एंड ट्रस्ट भी अच्छा मिलता है, राइट? ट्रस्ट भी अच्छा मिलता है. बट डिसएडवांटेज इज सॉलिड फ्यूल है, ज्यादा वेट लेगा, रॉकेट का ज्यादा वेट लेगा, राइट? ज्यादा स्पेस लेगा, राइट? सो दैट इज द डिसएडवांटेज. सो इट इज ए फाइव स्टेज ऑगमेंटेड एंड ऑल सॉलिड, राइट? ऑल सॉलिड. एंड पेलोड कैपेसिटी is 150 kg, right? Earlier SLV 40 kg, right? Now see here it is payload, right? That is the satellite which we are going to launch in the orbit, right? Into 400 kilometer circular orbits. That is lower orbits में भी that to 400 kilometers तक ही है, right? So with this payload, that is the augmented satellites का payload and the capacity, right? So 5 stages, right? 5 stages solid. So these are one stage, right? Stage 1, right? This is stage 2, right? So this is stage 3, and this is stage 4, and this is stage 5, right? So stage 5 के बाद all जैसे जैसे फ्यूल खत्म होगा इसको छोड़ के, राइट? ये यूजेबल नहीं कर सकता है, ये कहीं ओशन में गिर जाएगा, राइट? कहीं सी में गिर जाएगा, एंड देन दिस विल बी लेफ्ट, सैटेलाइट को रिलीज करेगी अपने ऑर्बिट में, राइट? सो दिस इज ASLV, राइट? एंड नेक्स्ट इज PSLV, राइट? सो दिस इज PSLV, right? PSLV, right? Polar Satellite Launch Vehicle. PSLV, right? So PSLV, when did it start? Right? This is India's third generation launch vehicle, right? First SLV हो गया, ASLV, then this is third generation launch vehicle, right? First successfully launched in 1994, right? 1994, right? And it is a four stage launch vehicle, right? 4 stages, and 4 stages में, that is first and third stage are solid fuel is used, and in second and fourth stage liquid fuel is used, right? Liquid fuel is used, and the liquid engine, right? भी सब में इंजन होगा, right? इंजन होगा तभी तो फ्यूल बर्न होगा, right? So the liquid engine which we use we call it as Vikas engine. So liquid engine which we use is Vikas engine. Vikas engine, right? The liquid fuel which we use is Vikas engine, right? So this is the 4-stage PSLV, and the payload capacity we will be discussing. So payload capacity is up to 1750 kg. 1750 kg, say it is very well improved into two sun synchronous polar orbits and 1400 kg into geosynchronous orbit. Geosynchronous orbits, right? So 1750 to sun synchronous polar orbit, 1400 kg into geosynchronous orbit, right? Right. So these are the, so PSLV, it is also called as work horse of ISRO, right? Most of the satellites are launched with using PSLV, right? अब देखो 4 stages है. See, this is first stage, right? This is first stage, and first stage में, right? First stage में, right? We will be using solid use करते हैं because mostly हर उसमें solid use करते हैं because अच्छा ट्रस्ट देगा, राइट? इनिशियली रॉकेट को शुरू से शुरू करना है, राइट? सो द इनिशियल ट्रस्ट विल बी गिवन वेरी गुड बाय द सॉलिड फ्यूल, राइट? सो सॉलिड ट्रस्ट, सॉलिड स्टेज, राइट? दिस इज सॉलिड, राइट? फर्स्ट स्टेज में सॉलिड यूज करेंगे. देन लिक्विड, राइट? लिक्विड फ्यूल, विकास इंजन लिक्विड, सेकेंड, right? And third is solid again, right? And fourth is again liquid fuel, liquid engine, right? Vikas engine is used for liquid, and here it is the payload or satellites which were sun synchronous orbit में, polar orbit में, and geosynchronous orbit में भी जा सकता है PSLV, right? Right. Now let's understand next, that is GSLV, right? So GSLV is 4th generation launch vehicle, first successfully launched in 2001, right? Geosynchronous satellite launch vehicle, right? Geosynchronous satellite launch vehicle. Now when it comes to GSLV, right, we have, right, GSLV 1, right? GSLV 1 तो है नहीं, right? We directly launched GSLV MK2, right? GSLV MK2, and then we launched GSLV MK3. So whenever we talk about GSLV, we will be talking about GSLV MK2. So that's why it is GSLV MK2. So GSLV MK1 कुछ नहीं है, right? GSLV 2 and GSLV Mark 3, right? So GSLV is a three-stage, right, satellite launch vehicle, right? 3-stage launch vehicle, and in this first stage is solid. By हर में first stage we will be using is solid because it gives good thrust, right? Then second stage is liquid, right? So liquid is what we use, Vikas engine, right? Liquid stage we use Vikas engine. Then third stage is cryogenic upper stage. So here we will be using cryogenic, right? And this is first stage, and this is second stage, and this is third stage, right? So this is cryogenic, right? This is liquid, this is solid, right? Solid stage, right? And payload capacity is 2250 kg in geosynchronous orbit, right? And up to 6 ton, 6000 kg in low Earth orbit, right? So 2250 kg in GSO and 6 ton in low Earth orbit, right? So GSLV used for launching GSAT and INSAT communication satellites, right? So this is with respect to. So now अब क्रायोजेनिक इंजन क्या है, क्रायोजेनिक क्या है, वो भी विल स्टडी while studying notes. So basically क्रायोजेनिक क्या है, क्रायोजेनिक में we'll be using liquid oxygen and liquid hydrogen, right? And cryogenic engines are very good, right? But it is very difficult to develop cryogenic engines because we need very low temperatures, right? That is minus 150 degrees Celsius, right? Or minus 200 degrees Celsius, 250, minus 250 degrees Celsius, right? To maintain these cryogenic fluids, that is liquid oxygen and liquid hydrogen, right? But उससे क्या होता है कि once we use cryogenic, right, we can reduce the weight of the fuel and we can increase the payload, right? Payload बढ़ा सकते हैं जैसे we will use cryogenic, right? So that is with respect to GSLV Mark III, right? Cryogenic. So we will be studying about cryogenic also, right? Now let's study about GSLV Mark III, right? See GSLV Mk3, right? So this is also a three-stage, right? Three-stage, right? Vehicle. First is solid, and first we will be using solid, right? So ये है, ये दोनों फर्स्ट स्टेज में we'll be using solid, and second is liquid. See this is liquid, and third is cryogenic, right? Third is cryogenic, right? Third is cryogenic upper stage, right? So first is solid, right? In solid stage we use HTPB, that is hydroxy terminated butadiene, right? No need to note down here, we'll be discussing in the class notes, right? Class notes mein. And in liquid stage we'll be using UDMH, right? That is unsymmetrical dimethyl hydrazine, right? And cryogenic stage mein we'll be using liquid oxygen and liquid hydrogen, right? And payload capacity is 4 ton to geosynchronous orbit, and up to 8 ton to low earth orbit, right? So that is, we are basically increasing the capacity, right? So this is the fifth, that is geosynchronous Mk2, right? These are the mostly now we are using PSLV, GSLV Mk2 and GSLV Mk3, right? Mk3 also we developed, and cryogenic we are initially relying on Russia, right? But now we have developed our own indigenous cryogenic engine, right? Mk3 mein we are using our own indigenously developed cryogenic engine, right? So now let's see next. See these are under development satellite launch vehicles of ISRO under development. ये सब बाकी आगे का डेवलप हुआ है, ये अभी डेवलप कर रहे हैं, राइट? सो फर्स्ट ऑफ दीज इज स्मॉल सैटेलाइट लॉन्च व्हीकल, राइट? स्मॉल सैटेलाइट लॉन्च व्हीकल, सी दिस इज स्मॉल सैटेलाइट्स, राइट? अभी बड़ा बड़ा सैटेलाइट्स, राइट? बड़ा बड़ा रॉकेट हर बार नया रॉकेट लाना, राइट? एंड रॉकेट को रीलॉन्च तो कर नहीं सकते, राइट? सो स्मॉल सैटेलाइट्स को जल्दी से जल्दी करने के लिए, राइट, वी आर डेवलपिंग दिस स्मॉल सैटेलाइट लॉन्च व्हीकल, राइट? सी दिस इज कंपैरिजन बिटवीन PSLV and SSLV, right? PSLV and SSLV, right? See height is PSLV का 44 meters. See 44 meters is very tall, right? That is एक 4 to 5 floor buildings का से भी बड़ा, right? Then SSLV का height is 34 meters, right? Diameter is 2.8 meters, diameter is 2 meters, right? Number of stages is 4 stages, and here it is 3 stages. See PSLV में we have seen, right? That is solid liquid stage, right? Here it is 3 stages, right? 3 stage solid propulsion stages, right? 3-stage solid propulsion stages, right? 3-stage solid propulsion stages, right? Right, and it is capable of launching mini, micro, and nano satellites of 10 kg to 500 kg, 500 kg mass to a 500 kilometer planar orbit, right? 500 किलोमीटर ऑर्बिट तक 10 kg to 500 kg तक 500 किलोमीटर्स तक ले सकते हैं. एंड हियर वन ऑफ द इंपॉर्टेंट थिंग टू नोटिस इज द टर्न अराउंड टाइम ऑफ 72 hours, right? Here turn around time is 60 days, right? That means शुरू से डेवलप करना है, कोई सैटेलाइट लॉन्च करना है, PSLV से लॉन्च करना है, राइट? इट विल टेक 60 days और 2 to 3 months, ठीक है, PSLV पूरा डेवलप करने के लिए इसरो को, right? Here the turn around is 72 hours, that is within 72 hours we can develop it, right? That is 3 to 4 days, right? And first flight we have tested in 2022, ये तो 1993 में हुआ था, right? So we test flight किया, right? अभी we are developing small satellite launch vehicles, right? Testing stage में है. And इससे क्या होता है, एक बार ये आ गया, so this will reduce time, right? Low cost space launch होगा, right? And flexibility to accommodate multiple satellites को accommodate कर सकते हैं, right? We can launch छोटे छोटे mini satellites, micro satellites, we can launch many satellites, right? And launch feasibility है by 72 hours में वो कर सकते हैं. Then turn around time is there and minimal infrastructure needs भी है, काफी वो होगा. So it will make, जैसे right now, right, we are launching very mini small satellites, right? बड़े बड़े satellites launch नहीं कर रहे थे, right? mini private satellites भी है, right? जैसे SpaceX है, right? SpaceX is launching number of satellites, small satellites into space. So like that ISRO also wants to develop, so that's why it has developed small satellite launch vehicle, right? The next is reusable launch vehicle technology demonstrator, right? Reusable launch vehicle technology demonstrator, right? RLVTD, right? Reusable launch vehicle technology demonstrator, RLVTD, right? That is reusable, right? जो भी लॉन्च किया, राइट, सैटेलाइट या रॉकेट लॉन्च किया, राइट, उसको रीयूजेबल. एंड हियर जब हम बात कर रहे हैं रीयूजेबल लॉन्च व्हीकल, वी आर नॉट टॉकिंग अबाउट एंटायर रॉकेट, राइट? जैसे हम रीयूज कर सकते हैं सिर्फ इस पार्ट को, जो पेलोड वाला पार्ट है उसको रीयूज कर सकता है, राइट? अंडर विच वी आर reusable launch vehicle technology demonstrator, it is at a technology demonstrator level, right? So इसमें unlike SpaceX क्या कर रहा है, इलॉन मस्क, he can use, see, stage 1 हो गया, हम लोग ये खत्म करके ये गिर जाएगा, राइट? स्टेज 2 हो गया, ये भी खत्म होके ये भी गिर जाएगा, इनको यूज नहीं कर सकते, राइट? व्हाट आवर रीयूजेबल लॉन्च व्हीकल, वी कैन रीयूज दिस पेलोड वाला पार्ट, राइट? एक बार जैसे क्या हो रहा था इसमें टेक्नोलॉजी डेमोन्स्ट्रेटर में, सी, ये सैटेलाइट को छोड़ देगी, अब ये डेब्रिस नहीं बन के रहेगी, ये दिस विल अगेन रिटर्न बैक टू द अर्थ, राइट? सो दिस रिटर्न बैक टू अर्थ, सी, एंड इन टेक्नोलॉजी डेमोन्स्ट्रेटर वी हैव बॉट इट, सी, पैराशूट वगैरह यूज करके, राइट? एंड चिनूक हेलीकॉप्टर भी यूज किया, सो इसको बोलते हैं, इसको पुष्पक, राइट? सो इट विल बी कमिंग बैक. सो अनलाइक स्पेसएक्स में क्या पूरा सैटेलाइट ही यूज कर रहा है, सो इसको फ्यूल हो गया तो ये बर्न नहीं होगा, राइट? दिस विल अगेन कम बैक, इसको पकड़ेंगे, राइट? इसको पकड़ के फिर दोबारा यूज करेंगे, इसको भी पकड़ के दोबारा यूज करेंगे, राइट? सो अवर रीयूजेबल लॉन्च व्हीकल, तो हम सिर्फ इसको रीयूज करेंगे. अगेन इट इज ऑल्सो ए वेरी इंपॉर्टेंट फीट, राइट? बिकॉज जिसमें भी काफी वो लगता है, राइट? मनी एंड एफर्ट, राइट? इफ वी कैन ब्रिंग इट अगेन, ये फ्यूल वाले यूज करके बना के तुरंत यूज कर सकते हैं, राइट? सो दैट इज देयर, एंड दीज आर वेरियस पार्ट्स ऑफ दिस पार्ट ऑफ द रीयूजेबल लॉन्च व्हीकल टेक्नोलॉजी डेमोन्स्ट्रेटर, ठीक है? जैसे ये करेंगे तो वो अगेन कॉस्ट कटिंग, राइट? अगेन लेस टाइम कंज्यूमिंग, राइट? ऑल दीज आर द फीचर्स. एंड अगेन एट द एंड, ठीक है, ह्यूमन स्पेस लॉन्च वगैरह में भी ये हेल्प हो जाएगा, राइट। एंड डेवलपमेंट ऑफ अदर टेक्नोलॉजीज ऑल्सो, राइट। दिस इज रीयूजेबल लॉन्च व्हीकल टेक्नोलॉजी डेमोन्स्ट्रेटर, राइट। ये डेमोन्स्ट्रेशन स्टेज में। देन नेक्स्ट इज ramjet, scramjet and dual mode ramjet, right? See again, ramjet is what? So, right, ramjet is a form of air breathing air breathing jet engine, air breathing jet engine. See what does it means? See, जब भी रॉकेट में देर इज ए फ्यूल, राइट। जैसे हम सॉलिड फ्यूल को यूज कर रहे हैं या लिक्विड फ्यूल को यूज कर रहे हैं या क्रायोजेनिक फ्यूल को वी आर यूजिंग, राइट। सो along with fuel we need some oxygen, right? some एयर में ऑक्सीजन चाहिए भाई, तभी तो जलेगा, राइट। अगर मान ले in our kitchens, if there is no oxygen in our kitchen rooms, right, we cannot light our gas, right, because for flame we need oxygen, right? So उसके लिए भाई ऑक्सीजन हमें हवा से मिलती है, राइट। अगर हवा से नहीं मिल रही है तो we need to take it the oxidizer along with the substance, right? जैसे क्रायोजेनिक है, लिक्विड ऑक्सीजन है, लिक्विड हाइड्रोजन है। सी लिक्विड ऑक्सीजन इज डूइंग व्हाट इज देयर, इट इज ऑक्सीजन प्रोवाइड करती है, राइट। सो अब उससे अगर मान ले हम ऑक्सीजन भी लेके जा रहा है और हाइड्रोजन भी जो जलेगा वो भी लेके जा रहा है, तो भाई इंजन का कॉस्ट बढ़ेगा, राइट, वेट बढ़ेगा, राइट। सो फॉर दैट इफ वी कैन टेक द ऑक्सीजन इज देयर इन द एयर, if we can take the oxygen from the air itself, right, then we can eliminate the need for carrying oxidizer, right, carrying oxygen, right. So air से ही अगर ऑक्सीजन लेके जेट इंजन जल सकता है, so that is called ramjet, right. And ramjet basically DRDO is working, right, and ISRO also wants to incorporate ramjet, scramjet and dual mode ramjet technology into its aircrafts, sorry, into its rockets, right, ताकि फ्यूल वेट कम करे, राइट, एंड फ्यूल कॉस्ट कम करे, राइट. सो दैट इज रामजेट, स्क्रैमजेट एंड ड्यूअल मोड रामजेट टेक्नोलॉजीज विच इसरो इज ट्राइंग टू अडॉप्ट, राइट. डीआरडीओ ने ऑलरेडी हमारे फ्लाइट्स में, राइट, फ्लाइट्स में इट हैज चेक्ड, राइट, इट हैज डेवलप्ड द टेक्नोलॉजी. एंड रामजेट उसमें मेन क्या है, रामजेट्स, राइट, रामजेट आर एफिशिएंट इन सुपरसोनिक स्पीड्स, सुपरसोनिक स्पीड्स, राइट, सुपरसोनिक स्पीड्स में ये एफिशिएंट है. स्पीड्स अप टू मैक 3, स्पीड्स अप टू मैक 3, राइट, दैट इज three times the speed of sound, right, and can operate up to मैक 6 तक, मैक 6 तक ऑपरेट कर सकता है रामजेट, राइट. एंड मैक 6 के बाद, राइट, रामजेट एफिशिएंसी ड्रॉप्स, राइट, रामजेट एफिशिएंसी ड्रॉप्स, राइट. सो दैट इज मैक 6 के बाद रामजेट एफिशिएंसी दैट इज एट हाइपर स्पीड्स, राइट, हाइपरसोनिक स्पीड्स, हाइपरसोनिक स्पीड्स में रामजेट काम नहीं कर सकता. सो नाउ अब हाइपरसोनिक स्पीड से अगर कोई भी जैसे मान ले डीआरडी को फ्लाइटर जेट, राइट, सो रामजेट इंजन is efficient at a supersonic speeds, that is from Mach 3 to Mach 6, right, and hypersonic speeds that is above 6 Mach, right. So we need scramjet engine, right. So scramjet, right, scramjet is an improvement over the ramjet engine, right. So scramjet, see, SC ramjet, right. So improvement over the ramjet engine as it efficiently operates at hypersonic speeds. So scramjet can operate at hypersonic speeds and allows supersonic combustion. So basically scramjet allows supersonic combustion at hypersonic speeds. So this is called that scramjet is nothing but supersonic combustion ramjet. Supersonic combustion ramjet, right? So basically hypersonic speeds में भी वो कर सकता है, right? And scramjet engine designed by ISRO uses, right, uses hydrogen as fuel and oxygen from atmosphere as oxidizer, right? Hydrogen fuel and oxygen from atmosphere as oxidizer use करेंगे. Then next is dual mode ramjet, right? Dual mode ramjet is where ramjet transforms into a scramjet, right? एक ramjet dual दोनों ramjet and scramjet. So ramjet engine है, right? It transforms into scramjet from Mach 4 to Mach 8 range, right? So that means कोई भी स्पीड है Mach 4 to Mach 8, so इधर Mach 3 to Mach 6 ही लिमिट है, right? So Mach 8 तक रेंज बढ़ाएगी with dual mode ramjet, right? That is the right, which means it can efficiently operate at subsonic and supersonic combustion modes, right? Subsonic and supersonic combustion modes, right? ये भी इसका भी पूरा इंफॉर्मेशन भी पढ़ेंगे, कुछ भी है तो nitty-gritties we will be understanding. Then next is next generation launch vehicles, right? Next generation launch vehicles, right? And government has started in 2024 the next generation launch vehicles program. Next generation launch vehicle program, right? Which aims to develop new launch vehicles, right? So next generation launch vehicles में क्या भाई, ये 3 stage vehicle है with reusable first stage. ये important, reusable first stage, right? जैसे Elon Musk SpaceX is doing reusable first stage, so we will be using the first stage as a whole, right? First stage सैटेलाइट जाएगी, फर्स्ट स्टेज का खत्म होने के बाद, फ्यूल खत्म होने के बाद फर्स्ट स्टेज अगेन आएगा दोबारा, जैसे इलॉन मस्क का वो पकड़ा, राइट, स्टेशन उस रॉकेट को, वैसे ही हम भी पकड़ के उसको दोबारा यूज करेंगे, राइट? फर्स्ट 3 स्टेज विथ रीयूजेबल फर्स्ट स्टेज को यूज करेंगे, रीयूज, राइट? सो नेक्स्ट जनरेशन लॉन्च व्हीकल्स, राइट? सो रीयूजेबिलिटी अगेन, लो कॉस्ट एक्सेस टू स्पेस एंड ग्रीन प्रोपल्शन सिस्टम्स भी होगा, राइट? एंड द बूस्टर स्टेजेस विल यूज, एंड अगेन वन इंपॉर्टेंट 3 स्टेज है, राइट? एंड द booster stage, right, booster stages will use semi cryogenic propulsion. Semi cryogenic propulsion, again an important point, right? Semi cryogenic, right? Semi cryogenic में क्या है भाई? पूरा cryogenic में we use cryogenic में, right? Cryogenic we are using liquid hydrogen and liquid oxygen, right? Which needs low temperatures, right? Semi cryogenic में we use refined kerosene as fuel, and liquid oxygen as oxidizer, right? We will use liquid oxygen as oxidizer, right? Cryogenic है, and refined kerosene as a fuel, that is non cryogenic, right? That's why it is called semi cryogenic. एक cryogenic है, एक non cryogenic है, right? So again, so एक oxidizer we need, right? Oxygen तभी fuel generate होगा, right? And refined kerosene as a fuel. So that's why, and it, while using this, it will increase 3 times the payload of GSLV जो present है, right? GSLV, PSLV etc, right? उनका 3x payload increase होगा, right? So that is the next generation launch vehicles, right? So these are the things. Now let's go to the class notes and we will read whatever we have understood now, right? Right. So now let's see ISRO's satellite launch vehicles, right? Launch vehicles are used to transport and put satellites or spacecrafts into space, right? Into its orbits, right? So first is SLV, satellite launch vehicle, right? So the first experimental satellite launch vehicle was developed in 1980. It was a four-stage all solid launch vehicle that launched 40 kg of payloads into low earth orbit, right? Into low earth orbit, all four solid, right? And on July 1980, it had successfully launched Rohini Satellite 1 from Sriharikota, making India seventh member of an exclusive club of spacefaring nations. Right, Rohini 1 satellite launch kiya using SLV 3. SLV 3. Right. So in 1980. Then next is augmented satellite launch vehicle, augmented version of SLV. Right. Successfully in 1992, and it is a five-stage all solid launch vehicle with a mission of orbiting 150 kg payload, right, into 400 kilometer circular orbit, right? Currently PSLV, GSLV and GSLV Mark III are active operational launch vehicles of India. That means these two became inactive, right? अभी यूज ही नहीं कर रहे, right? So PSLV, GSLV and GSLV Mark III. So PSLV, right? So PSLV, India's third generation launch vehicle, first successfully launched in 1994, right? It is a four-stage launch vehicle, right? First and third stage are solid, right? And second and fourth stage are liquid, right? हमने देखा भाई फर्स्ट स्टेज में तो सॉलिड ही होगा हमेशा बिकॉज हायर थ्रस्ट मिलता है, राइट? एंड लिक्विड जो होगा लिक्विड इंजन दैट इज कॉल्ड विकास इंजन, राइट? विकास इंजन, right? Liquid engine is called Vikas engine, right? And payload capacity is 1750 kg to sun synchronous polar orbit still 600 kilometers and 1425 kg into geosynchronous orbit, right? Due to PSLV's unmatched reliability, numerous satellites including satellites from IRNS constellation have been launched into geosynchronous and geostationary orbits, right? It successfully launched Chandrayaan 1 in 2008, Mars orbiter spacecraft in 2013, right? A few examples hai, which we can remember, right? Then GSLV, right? GSLV, whenever we are talking about GSLV, we are talking about GSLV Mk2, right? Is a fourth generation launch vehicle, first successfully launched in 2001, right? Three-stage launch vehicle, first is solid, second is liquid, Vikas engine, and third is cryogenic upper stage. And in 2001 we used Russian cryogenic technology, right? Russian cryogenic technology, right? We haven't developed it then, right? And payload capacity 2250 in geosynchronous orbit, 6 ton in low earth orbit, right? GSLV is used for launching GSAT series, INSAT series communication satellites, GSAT series, INSAT series communication satellites, right? Then GSLV Mk3, right? Geosynchronous satellite launch vehicle Mk3, right? Mk3, that is next generation launch vehicle of ISRO, right? Three stage launch vehicle, first is solid, right? First तो हम solid ही use करेंगे, right? And second is liquid and third is cryogenic per stage, right? And solid में we are using HTPB, hydroxy terminated butadiene, and liquid में we are using unsymmetric dimethyl hydrazine, right? And cryogenic way we will be using liquid oxygen as oxidizer and liquid hydrogen as fuel, right? Payload capacity 4 ton into geosynchronous, 8 ton into low earth orbit, right? Now let's discuss about cryogenic engine, right? Cryogenic engine or cryogenic stage is the last stage of space launch vehicles which makes use of cryogenics, Cryogenics is the study of the production and behavior of materials at extremely low temperatures, right? Cryogenics is study of the production and behavior of materials at extremely low temperatures to lift and place the heavier objects in space, राइट, हेवियर ऑब्जेक्ट्स इन स्पेस में रखने के लिए, राइट। क्रायोजेनिक इंजन मेक्स यूज ऑफ लिक्विड ऑक्सीजन एंड लिक्विड हाइड्रोजन एज प्रोपेलेंट्स विच लिक्विफाई एट, राइट। ऑक्सीजन एंड हाइड्रोजन है भाई, ये तो गैसेस है, राइट। दे लिक्विफाई, टू लिक्विफाई देम वी नीड टू bring temperatures as low as -183 degrees ऑक्सीजन को करने के लिए एंड -253 degrees respectively to liquefy hydrogen, राइट। सो इसीलिए भाई ये इतना टेम्परेचर कम लाना इज नॉट एन इजी थिंग, राइट। इट इज ए वेरी टेक्निकल प्रोसेस, राइट, इनको बनाना, राइट। एंड liquid oxygen and liquid hydrogen are stored in their respective tanks, right. Typically these engines use a combination of liquid oxygen as the oxidizer and liquid hydrogen as the fuel, right. ऑक्सीजन ऑक्सीडाइजर चाहिए भाई, फ्यूल के लिए हाइड्रोजन, राइट। द यूज ऑफ क्रायोजेनिक फ्यूल allows for high performance and efficiency in rocket engines, right. Hydrogen and oxygen are extremely clean fuels, right. When they combine they give out only water, see ये भी important है, right। इससे पोल्यूशन भी नहीं होगा, जो रॉकेट फ्यूल की वजह से पोल्यूशन होता है, रॉकेट एमिशंस, राइट, वो भी नहीं होगा बिकॉज दे आर क्लीन फ्यूल्स एंड व्हेन दे कंबाइन दे गिव आउट ओनली वाटर, ये भी इंपॉर्टेंट है, प्रीलिम्स में दे कैन आस्क, राइट। दिस वाटर इज थ्रोन आउट ऑफ द नोजल इन द फॉर्म ऑफ हॉट वेपर के रूप में आएगा, राइट। दस द रॉकेट इज नथिंग बट ए high burning steam engine, right. So for Chandrayaan 3 mission CE-20 cryogenic engine was used, Chandrayaan 3 mission के लिए cryogenic engine was used, right. CE-20 was India's first cryogenic engine with a gas generator cycle and the largest cryogenic engine to be made by ISRO. It took its first flight in June 2017, right. 2017 में we have developed indigenous cryogenic engine, right, with cryogenic technology, right. So that is with respect to cryogenic engine. Then the satellite launch vehicles of ISRO under development, right, under development stage, they are small satellite launch vehicles, right. Small satellite launch vehicles we to develop to launch mini, micro or nano satellites up to 10 kg to 500 kg mass to a 500 kilometer planar orbit, 500 kilometer planar orbit, right. So SSLV is a 3-stage launch vehicle configured with 3 solid propulsion stages and liquid propulsion based velocity trimming module as a terminal stage, right. So basically 3 stage वो है, ये इतना important नहीं है, right. 3 stage launch vehicle है, right. And key features are small, low cost with low turnaround time, right, and flexibility in accommodating multiple satellites and launch on demand feasibility, right. Minimal launch infrastructure requirements etc we have discussed, right. Then reusable launch vehicle technology demonstration stage में, right, reusable launch vehicle, right, is one of the most technologically challenging endeavors of ISRO towards developing essential technologies for a fully reusable launch vehicle to enable low cost access to space, right. In future this vehicle will be scaled up to become first stage of India's reusable 2-stage orbital launch vehicle, right. We have discussed the ISRO's reusable launch vehicle look like a aircraft, Pushpak we have seen in the image, right. It consists of a nose cap, fuselage, double delta wings, twin vertical tails etc, right. Basically जो features है, right, जो पुष्पक मेंशन किया इमेज में उसका फीचर्स, राइट. देन द RLD will be used to develop technologies like hypersonic flight, autonomous landing, return flight experiment, powered cruise flight, scramjet propulsion experiment, basically इनमें भी हेल्प करेगा, राइट. एंड सिग्निफिकेंस, राइट, कंसिडर लो कॉस्ट, रिलायबल, ऑन डिमांड मोड ऑफ एक्सेसिंग टू स्पेस, राइट. कॉस्ट नियरली 80% कम कर सकता है, राइट. Then next is scramjet engine and ramjet engine. See, scramjet engine, right. See, the first experimental mission of scramjet engine towards realization of air breathing propulsion system, right, was successfully conducted in 2016 by ISRO. 2016 में इसरो सक्सेसफुली, एंड इंडिया इज द फोर्थ कंट्री टू डेमोन्स्ट्रेट द फ्लाइट टेस्टिंग ऑफ स्क्रैमजेट इंजन, राइट, फोर्थ कंट्री, सो ऑलरेडी डेमोन्स्ट्रेट किया है, राइट, इट इज इन डेवलपिंग स्टेज, राइट. व्हाट इज स्क्रैमजेट इंजन? स्क्रैमजेट इंजन इज ए एयर ब्रीथिंग प्रोपल्शन टेक्नोलॉजी, भाई एयर से ऑक्सीजन लेती है, राइट, ताकि ऑक्सीजन फ्यूल लेके ना जाना पड़े, ऑक्सीडाइजर, राइट, जो ऑक्सीजन लिक्विड ऑक्सीजन को एज ऑक्सीडाइजर वी आर यूजिंग, राइट, सो नो नीड टू टेक दैट, वी कैन द एयरक्राफ्ट or rocket can directly breathe oxygen from the air and propels, right. Air breathing propulsion technology utilizes atmospheric oxygen for combustion, eliminating the need to carry oxidizer, right, eliminating the need to carry oxidizer, right. It provides a technological key for low cost space transportation systems and improves the payload fraction. भाई एक तो ऑक्सीजन ऑक्सीडाइजर कैरी करने की जरूरत नहीं है, उसकी जगह पेलोड बढ़ा सकते हैं, राइट. देन ऑक्सीडाइजर यूज करने की लिक्विड ऑक्सीजन डेवलप करने की जरूरत नहीं है, राइट, सो लो कॉस्ट कम कर सकते हैं, राइट. सो देयर आर थ्री मेन टाइप्स ऑफ एयर ब्रीथिंग प्रोपल्शन टेक्नोलॉजी, राइट. दे आर रामजेट, स्क्रैमजेट एंड ड्यूअल मोड रामजेट, राइट. सो रामजेट इज ए फॉर्म ऑफ एयर ब्रीथिंग जेट इंजन, right, that uses the vehicle's forward motion to compress incoming air for combustion without a rotating compressor, right. vehicle का forward motion है, right, to वो यूज करती है टू कंप्रेस इनकमिंग एयर को कंप्रेस करके, राइट, कंबशन में यूज करती है विदाउट रोटेटिंग कंप्रेसर भी जरूरत नहीं है, राइट. फ्यूल इज इंजेक्टेड इन द कंबशन चैम्बर वेयर इट मिक्सेस विद हॉट कंप्रेस्ड एयर एंड इग्नाइट्स, राइट, हॉट कंप्रेस्ड एयर से मिलके इग्नाइट करेगी. ए रामजेट पावर्ड व्हीकल रिक्वायर्स एन असिस्टेड टेक ऑफ, राइट. ए रामजेट इंजन नीड्स असिस्टेड टेक ऑफ, भाई इनिशियली फ्यूल चाहिए, राइट, इनिशियली ऑक्सीडाइजर भी चाहिए, राइट, बिकॉज असिस्टेड टेक ऑफ लाइक ए रॉकेट असिस्ट टू एक्सेलरेट इट टू ए स्पीड वेयर इट बिगिंस टू प्रोड्यूस थ्रस्ट, राइट. तो उस स्पीड तक पहुंचने के लिए चाहिए, राइट. रामजेट वर्क्स मोस्ट इफेक्टिवली एट सुपरसोनिक स्पीड्स अराउंड मैक 3, राइट. सो जैसे इसी स्पीड में भाई ये व्हीकल का फॉरवर्ड मोशन टू कंप्रेस इनकमिंग एयर, राइट, उसके लिए मैक 3 स्पीड जरूरी है, राइट. सो इफेक्टिव एट मैक 3 स्पीड 3 टाइम्स द स्पीड ऑफ साउंड, राइट. उस स्पीड में ही हवा के में ऑक्सीजन जो है उसको यूज कर सकती है, राइट. सो उसके लिए इनिशियल ट्रस्ट चाहिए, राइट. इनिशियली हमें उस स्पीड अटेन करने के लिए तो जाना पड़ेगा, कुछ तो करना पड़ेगा, फ्यूल वगैरह चाहिए, राइट. देन वंस इट रीच मैक 3 इट कैन स्टार्ट यूजिंग द एटमॉस्फेरिक ऑक्सीजन एंड कैन ऑपरेट अप टू स्पीड्स ऑफ मैक 6, राइट. एंड ये मैक 3 एंड मैक 6, सो M3 टू M6 तक ही रामजेट काम कर सकती है, right. However, the ramjet efficiency starts to drop when the vehicles reach hypersonic speeds. Hypersonic speeds में जाएगा तो ramjet काम नहीं करेगा, right. Then scramjet engine is an improvement. Scramjet is supersonic combustion ramjet, right. Scramjet is SC, supersonic combustion ramjet, right, is an improvement over ramjet engine as it efficiently operates at hypersonic speeds, right. हाइपरसोनिक स्पीड्स में काम कर सकती है एंड allows supersonic combustion. So supersonic combustion at, right, hypersonic speeds. Thus it is known as supersonic combustion ramjet. Supersonic combustion ramjet. The scramjet engine designed by ISRO uses hydrogen as a fuel and oxygen from the atmospheric air as the oxidizer. So hydrogen लेके जाएगी, राइट, हवा से ऑक्सीजन को यूज करेगी एज एन ऑक्सीडाइजर. देन नेक्स्ट इज ड्यूअल मोड रामजेट. ड्यूअल मोड रामजेट, सो इट इज टाइप ऑफ जेट इंजन वेयर ए रामजेट ट्रांसफॉर्म्स इनटू स्क्रैमजेट, राइट. रामजेट ट्रांसफॉर्म्स इनटू स्क्रैमजेट ओवर मैक 4 to 8 range, over Mach 4 to Mach 8 range, which means it can efficiently operate both in subsonic and supersonic combustion modes, right. दोनों स्पीड्स में भाई Mach 4 to Mach 8 रेंज में वो कर सकती है, राइट. देन नेक्स्ट इज नेक्स्ट जनरेशन लॉन्च व्हीकल, राइट. नेक्स्ट जनरेशन लॉन्च व्हीकल, राइट. इन 2024 government has approved next generation launch vehicle program, right, which aims to develop new launch vehicles, which aims to develop new launch vehicles, right? So NGLV, next generation launch vehicle, is a three-stage vehicle, with reusable first stage, right? Right, ये important है, reusable first stage, right? We have discussed, right? First stage के बाद we can use the first stage fuel का parts, right? और उसका engine etc, right? Fuel ही burn होगा, engine को use कर सकते हैं. The reusability results in low cost access to space and modular green propulsion systems, right? So the booster stages will use semi cryogenic propulsion using refined kerosene as fuel and liquid oxygen as oxidizer, right? Refined kerosene as fuel. It will have 3 times the present payload capability with 1.5 times the cost compared to LVM3, right? So it will have 3 times the present payload capability with 1.5 times the, right? We have already discussed. So, right, with this we are done, right? Next we will be discussing satellites.